So right now, all the buzz, all the headlines, they're about one kind of AI, the AI that learns from massive amounts of data. But what if I told you there's another kind? A forgotten ancestor, an AI that was built not on data, but on pure, cold, hard logic. Let's dig in.
Right off the bat, you gotta understand that we're talking about two totally different philosophies here. On one side, you've got the AI that learns. This is the AI you know today. It's all about pattern recognition. It feels super intuitive and fast. And yeah, it's the powerhouse behind deep learning. But on the other side, there's an AI that reasons. This one is deliberate, it's methodical, it's step by step, and it's built on a foundation of logic and rules. That, my friends, is classic symbolic AI.
So first up, we're going to explore this forgotten ancestor. We're going to see how that original dream of a truly thinking machine wasn't built on crunching data, but on something much more elegant, pure logic. So what is symbolic AI really? Well, think of it this way. It's an approach based on things we humans can actually read and understand: symbols, facts, and rules. The whole idea was to give a computer a big library of knowledge and a set of logical rules, and then let it chew on that knowledge to solve problems. Kind of like how you or I would sit down and work through a really tough logic puzzle.
And this idea, well, it led to what you could call the golden age of logic. In those early days, the optimism was just off the charts. Some people even called it irrational exuberance, because everyone was so sure that a real, honest-to-goodness thinking machine was right around the corner.
Now what's wild is that the history of AI wasn't this smooth, steady climb. Not at all. It was more like a roller coaster, with these massive, super-hyped summers of progress, followed by these crushing winters of disappointment. The first summer in the 50s and 60s was incredible, but when big promises like perfect translation or autonomous tanks for DARPA didn't happen, the money just dried up. Poof, first AI winter. But then, in the 80s, a brand new idea sparked a second summer. But here's the thing. Even during this golden age, the AI community wasn't one big happy family. It was split. On one side, you had the NEETs, mostly at Stanford and Carnegie Mellon. They believed true intelligence could come from pure, clean, formal logic. On the other side, you had the Scruffies at MIT. They argued that intelligence is messy, it's complicated, and you need custom, hand-built, ad hoc solutions to get anything done. It was this incredible debate about the right way to build a mind. That debate was fierce, but the idea that really kicked off that second AI summer came down to this one powerful concept, summed up perfectly by a pioneer named Edward Feigenbaum: in the knowledge lies the power. It's so simple, right? If you want a machine to be smart, you have to give it knowledge. And this single idea led to the creation of expert systems. And these things, honestly, they were amazing. You had Dendril, which could figure out the structure of complex molecules. You had Mycin, which could diagnose bacterial infections just as well as a human doctor. Caduceus could diagnose 1,000 different diseases. For a while there, it really looked like this was it. This was the future.
And to see just how big a deal this was commercially, look at this. Back in the 80s, Digital Equipment Corporation had these huge, complex computer systems. Putting one together was a nightmare. It took a human expert, on average, 90 days.
Then they built their expert system, XCon. It did the same exact job in 90 minutes. That kind of improvement is just staggering. It saved them millions. And you can bet other companies noticed. By 1988, DuPont had 100 of these systems running, with 500 more on the way. The boom was very, very real.
But you know how these stories go. What goes up must come down. Just as fast as this logical dream had risen, it started to crack, and that brought on the long, cold AI winters.
So what happened? Well, it really boiled down to three killer problems. First, what they call the knowledge acquisition bottleneck. Just getting all that human knowledge into the machine, rule by painful rule, was incredibly slow. Second, the systems were brittle. They were absolute geniuses inside their little box, but the second you gave them a problem they hadn't seen before, they just shattered. And finally, you had the frame problem, which is just this mind-bendingly difficult challenge of teaching a computer all the common sense stuff. Like, if you look up a number on your phone, how does the AI know the phone is still a phone and the walls are still the same color? You'd have to program every single one of those obvious facts. It's impossible.
And it wasn't just the researchers who saw these cracks. The outside world started noticing too. In the UK, a huge government report basically said that these successes on toy problems were great, but they would never scale up to the real world. Why? Because of something called combinatorial explosion. Basically, the real world is just too messy with too many possibilities for any hand-coded system to handle. Reports like that led to massive funding cuts, and that kicked off the second, even colder AI winter. But just as the lights seemed to be going out on the whole field of AI, something started stirring. An old idea, one that had been cast aside for years, was about to make the comeback of a lifetime: the neural network.
I'm not exaggerating here. For the entire world of artificial intelligence, everything, and I mean everything, changed in the year 2012.
You have to remember, neural networks weren't new. They'd been around for decades. But for most of that time, pretty much everyone agreed that the whole approach was, well, hopeless. It just didn't work well enough. It wasn't until we got massive datasets, big data, and the powerful computer chips to process it all that their true potential was finally unlocked. And when the revolution came, it was fast, and it completely turned the field on its head.
That breakthrough moment came from a system called AlexNet. In 2012, it absolutely demolished the competition in an image recognition contest. And after that, the dominoes just started falling. Boom! Deep learning starts crushing speech recognition. Boom! Machine translation. Boom! Generating realistic images. The list just kept growing, solving problems that symbolic AI had struggled with for half a century.
And that brings us right up to today, to what might be the most exciting chapter yet: the idea of a hybrid AI. This isn't about one team winning and the other losing anymore. This is about forming a powerful alliance, an alliance between learning and reasoning.
So is that really the whole story? Is AI just one big battle between logic and learning? A zero-sum game where one of them has to come out on top? Well, the new thinking is no, absolutely not. And maybe the best way to understand this is through the idea of thinking fast and slow. It's this concept that says our own minds have two different systems. There's system one, which is fast, automatic, intuitive. It's great at pattern matching. Sound familiar? That's basically deep learning. Then there's system two, which is slower, more deliberate, step by step. It's what we use for planning and logical deduction, and that is a perfect description of symbolic AI. A truly complete intelligence needs both.
So, the future isn't one or the other. The future's almost certainly neuro-symbolic. It's about taking the amazing, intuitive pattern matching of neural networks and combining it with the careful, rigorous logic of symbolic systems. You get the best of both worlds.
And this isn't just some theory, you know. Researchers are actively building these hybrid brains right now. A great example is AlphaGo. It uses a neural network for the intuitive feel of the game, but then uses a symbolic search to logically plan out its moves. Other models use a neural net to see and hear the world, and a symbolic system to reason about what to do next. The point is, there are tons of real, concrete ways people are working on merging these two incredible approaches to intelligence.
And all of this leaves us with one final, absolutely fascinating question. For decades, we chased two different dreams for AI. One built on learning, the other on logic. Now, as we're finally starting to fuse them together, you have to wonder, what new kind of intelligence is going to emerge when we create machines that can not only learn the way we do, but can also reason with a speed and a rigor that we can only dream of?